The next thing that we're going to see is this famous Millikan's oil drop experiment, which help us to know the charge of an electron. So nowadays in your exam paper, they give you in the data sheet that the charge of an electron is 1.6 into 10 to the minus 19 coulombs. But this story is happening back then, where we had no idea what is the charge of an electron. It's called Millikan's oil drop experiment. I don't know what is this issue with scientists. They're always interested in dropping something. So Galileo is dropping the ball from the Pisa Tower, and now Millikan is dropping oil, except they don't drop their ego. In fact, the more you learn science, it's difficult to drop your ego, drop the mind. The mystic I was talking to you about the other day, Krishnamurti, so he had a conference with a bunch of scientists and all these professors. At the very beginning of the conference, he said that all thoughts lead you to suffering, and immediately they started disagreeing and like kind of arguing, and the mystic Krishnamurti later comments that the investment of a scientist in his mind is so much, in his knowledge is so much, that he can't even dare to question the utility or the usefulness, the actual usefulness of it. So scientists are always interested in dropping balls and oil drops, but they're not interested, even least interested, in dropping their mind or ego. So if you're getting poor marks for science, if you are not good in science, perhaps it is a real blessing rather than being good in science. Perhaps you might not have a good car or a better house or better respect, but you will not lose your heart. Okay, so coming back here, so oil drop experiment, despite all that comments about the scientists, this is one of the most beautiful experiment. And beauty is important because Tolstoy says that beauty makes the heart inclined towards love. So this is a very beautiful experiment. So let's look at how it functions. So what he does is he takes he is spraying oil drops through this small hole, and when they are sprayed, due to the friction of being coming out of the nozzle, the oil drops become negatively charged. Whatever the relevant material and setup required is met, and the oil drops, when they leave the nozzle, is negatively charged, and they are coming down, they are falling under their gravity. At the same time, this parallel plate has an electric field. The important thing to realize is that the field lines are of course going to be from top to bottom equally spaced. Okay, so if you want to show the equal spaced nature, then there should be at least 3 lines, and it should occupy the entire length of the parallel plates. Now this direction shown by the field lines is the direction in which a positive charge would move. Now this oil drop is negatively charged. Of course it has to be negatively charged because there is already a downward force mg acting on the oil drop. If it needs to be balanced and kind of suspended in air, then you need to have a force that is acting upward. Now this electric field, if it would be giving a downward force on a positive charge, then in a negative charge it would give an upward force, right? The electric force would be upward. Now it is very tempting to think that a negative charge will be attracted by the positive charges and will be repelled by the negative charges, hence there will be an upward force. It is because that's how you used to argue, the positive charges attract and negative charges repel. So but if you write that in the exam, that the positive charges in the top plate are attracting the oil drop and the negative charges in the bottom plate are repelling the oil drop, you will not get marks, because as I said in the earlier video, now you should start talking in terms of the field. It is not like two forces, because when you, the reason why you should not say so is, when you say so, it sounds like that there are two forces and the electric force is the resultant of those two. But actually there is only one electric force that is created by the electric field. So hereafter your argument should be that the electric field is downward and the oil drop is negatively charged, hence it will have an upward force. Okay, now what we will do, or what Millikan did, is this plate, the parallel plates are connected to a setup whose potential difference can be varied. So you can look at the symbol. If you remember, it's like a variable resistor, but here we have the batteries. So that means the potential can be varied, right? Now we know that the electric field strength is equal to F over Q, and let's say that the charge here is, charge on the oil drop is small q, then the force experienced is, but the electric force experienced is going to be electric field strength into charge. This is the electric force is equal to be electric field strength into charge. At the same time, we have the other equation, E is equal to V over D. The electric field strength is equal to the potential difference divided by the separation, which means that the electric field strength, if you substitute for E, if you take this E and substitute here, you will get that the electric force is equal to VQ over D, right? The electric force would be equal to VQ over D. So you can see by the separation is remaining, the separation remains constant. The charge on the electric on the oil drop remains constant. So by varying the potential difference between the plates, you can change the upward force. And the moment you strike the point where the electric force equals the weight, okay, when you have the right potential difference where the electric force equals the weight, then what's going to happen is a very beautiful frozen frame kind of effect, where the oil drop is going to be suspended in mid-air. Just try to visualize the beauty of it. There is an oil drop which is like a pearl, oily, shining droplet, and it is just there like a hot air balloon or a hovering helicopter suspended in mid-air. Isn't it beautiful? So that condition for equilibrium, if you apply that condition for equilibrium, that means the electric force, okay, the electric force should be equal to the gravitational force, that is basically QV over D. Okay, the QV over D should be equal to the gravitational force mg, and from that they found that the charge on the oil drop is equal to V, right? But something even more interesting, even more beautiful happened thereafter. They changed the amount of charge on the oil drop, and they used different potential differences to balance it, and something that was unexpected was happening. That is, whatever the charge of the oil drop that they were calculating, that charge was always an integral multiple. Whatever the Q value, first they use a Q1 value, that is N1 times this particular number 1.6 into 10 to the power 9 minus 19 coulombs. Then they used another amount of charge on the oil drop. That is again, when they calculated it, that is also equal to another integral multiple of this number. Again they used something else, and again and again and again and again it seemed to come back to this magical number 1.6 into 10 to the power minus 19 coulombs. And that led to a particular understanding that, where is that word? Charge is quantized. These are three beautiful words. Charge is quantized. That means that the charge in existence in universe is not going to take any random value that you desire, but it will always be available in as a multiple of a particular minimum quantity. Just think that a very famous pickpocket thief goes to a particular city, a particular new country, and he finds out that whatever the money that he gets from different purses, from different pickpockets, they are always an integral multiple of, say, 3 rupees or $3 or £3. What would he conclude? He would conclude that the minimum currency in that country is $3. If he goes to another country and if he finds out that the money that he is getting in his pickpocket is always an integral multiple of 50 cents, then he would say that 50 cents is the minimum currency available, assuming this is happening in Sherlock Holmes or times where there is no ATM or digital banking. So the fact that these charges are always an integral multiple of this special number 1.6 times 10 to the power minus 19 coulombs says that charge is quantized, that you can't have charge in any amount that you desire, but always as a multiple of a certain particular amount. And obviously the source of negative charge is understood as the electron. So hence this particular minimum charge was ascribed, so it was kind of given or kind of inferred to be the charge of the electron. Okay, so they first find out that charge is always a multiple of a minimum value, and then they think that electron is the minimum negative charge in existence. Hence this minimum value should be the minimum, hence this minimum value should be the charge of the electron. And that's the story of how they found the charge of an electron.